Okay, so we're moving on to 2.11, which is calculating the unknown side with the tangent ratio. Okay, so what was our acronym we used again for tan? TOA, right? So TOA standing for what? Correct. So it means tan. So tan of an angle is equal to the opposite side length over the adjacent side length. So we've always tried to find, in our last couple examples, the ratio between those two sides, which help us find the angle. Now we're going to have the angle, and we're going to have to find the unknown side. So we're either going to have to find the opposite or the adjacent side based on having the angle and one of the side lengths, okay? So we're going to have one angle and one side length, and we're going to have to figure out the unknown side length, okay? So the instructions are pretty simple as follows. Show all your work to guarantee full marks, and to round off your answers to your tangent answers to 4 decimal places, okay? So every question you do on a test will tell you whether you're going to round something to the nearest degree, whether you're going to round it to 1 decimal place or 4. Typically with the ratios, we do 4. With the side length, we do 1. And with a degree or an angle, we usually go to the nearest degree. It just makes things a lot easier for us as we go through. So it says calculate an unknown opposite side with the tangent ratio. So the example is below. Calculate the measure of the unknown opposite side. Round off your answers to 1 decimal place if necessary. I'm just going to make this a little bigger so we can see it there. So if we look at this right here, we have triangle ABC. What is the angle in reference here? Which angle are we using? Yep. No. A, right? So A, so remember that X is a side length and 5 would be a side length. So when we're discussing side lengths, it would be BC or AC or AB. When we're talking about an angle, angles are within the triangle, right? So that's a 90-degree angle. This angle right here is 27 degrees. It shows us that, okay? And that little box there means 90 degree, and then we don't know the angle of B right there, okay? So if we were to say this was the angle in question, what side is this called right here? The hypotenuse, right? What side is this side right here? The adjacent. And then X would be what? The opposite side, exactly. So we've been given an angle in question, and sometimes they're going to just give us exactly what we need to find. So in this case, they've told us we're going to find the opposite side with the tangent ratio. So we know that our unknown is the opposite, okay? So we know TOA is our acronym we're going to use with tan, and it's tan X equals opposite over adjacent. And then we can begin to fill in our different terms. So it would be tan what then? Yep. So it technically is A, but what do we have a measure for it? 27, exactly. So it's going to be tan 27, okay? Because we've been given that answer, that angle. And then the opposite side, do we have a length for that? No. What's in its place? X over, what's the adjacent side? 5.0, okay? So on our calculators, we can do tan 27 or 27 tan. Somebody can do that and let me know what you get. So it's four. We're going to do 4 decimal places with the beginning here, but you're on the right track for sure. 0.5095, okay, is equal to x over 5.0. No, we're looking at this like, oh my goodness, what is going on? But what have we done in our earlier in the unit with similar sides and proportions that can prepare us for this? Well, we don't divide it. So yeah, what's that term called again? Starts with a C. Cross multiplication, right? So if any number we have, okay, if we have just a whole number, it's always over 1, okay? Because if you divide it by 1, it's just itself. So if we did cross multiplication in this case, the 1 would come up here, the 5 would come up there, and then we would be, sorry, I got to do this big arrow over here, but it would be 0.5095 times 5.0, and then it would equal x times 1. What's x times 1? Just x, right? Like it's just the same, okay? So we've done cross multiplication. So then if we multiplied 0.5095 by 5, we should get an answer. Anyone? Yeah, so 2.547 whatever. But we know in this case we're going to round, it said round side lengths to 1 decimal, so it would just be 2.5 centimeters. Okay? So those skills that we learned earlier in the unit with cross multiplication are becoming very important now, because you're going to see that you're going to have to use them pretty often. Okay? Does anyone have questions about that? Or do you feel that just the more examples we do, we might get a better handle on it? Yeah. Well, you don't have to. So I just put it there to show you that's what we're doing with cross multiplication. So that's a really good question. I could have equally just done this. And the rationale behind that is we still do cross multiplication, but are we multiplying x by anything? No, we're not really. Like you can leave that out if you like. Another way to look at it is if I have x over 5, what does that mean basically? I'm doing what to x? I'm dividing x by 5. That's what that means. So whenever we have a fraction, if I have a fraction that's 2 over 3, all it means is I'm dividing 2 by 3. So in this case, I'm dividing x by 5. Now, if I want x by itself on one side, we have to do the opposite operation. So if it's division on this side, what do we have to do on the other side? Division on one side. If we want to bring it across equal sign, we have to do the opposite of division, which is multiplication. So that's where we get the whole cross multiplication thing. So if it's division on both sides underneath, that's why we bring both of those numbers up, because they go from division on one side of the equal sign, and if we bring them over to the other, we have to do the opposite of it, and the opposite of it is multiplication. Does that make a little bit more sense? Cool. All right. Moving on. So calculating an unknown adjacent side with the tangent ratio. So calculate the measure of the unknown adjacent side. Round off your length answers. So just the length answers to 1 decimal place. We'll do our tangent answers to 4 decimal places, okay? Hopefully you can read my writing. So what is we've got triangle DEF, what is our angle in question here? Or what is the angle that we have? Yep, exactly. So angle D, or 32 degrees, is our angle that we know. So by looking at this triangle, what side is our opposite? Sure. What side is our hypotenuse? D to E. And then finally, our adjacent side, X, or D to F, right? Awesome. So again, we're doing nothing different than we did the other day when we first set these up. We find our angle in question. Sometimes it will have a little X or a little circle or a little check mark. But in this case, we're given those angles, so we know it's there. And then we just fill out the rest of the triangle there. So based on TOA, what's our equation? Tan X is equal to opposite over adjacent. Always show this step, guys. It's good to get in the habit of it, especially because we're going to be introducing two other ratios, sine ratio and cos ratio eventually. So you're going to really want to write this stuff out. I know it seems simple now because we're just doing the one, but once we have three different options, it's going to make a lot more sense to do it. Okay, so what can I fill in then? What would it look like? Yep. Wicked. Cool. Great job. So now cross multiplication is going to become very different. So in this case, we want to get the X by itself. Okay, that's our goal. Always, whenever we have any variables, we want to get it by itself. First things first is we want to do 32 tan or tan 32. Anyone have that? Yep. 6, 2, 4, 8, or 9. Should be 6, 2, 4, 9 technically, but just if we round it to 4 decimal places. But yeah, it's 6, 2, 4, 8, 6, 9, whatever it ends up being. 77 different numbers after that. If we round that, that's what it goes to. And then we have 7.2 divided by X. Now, to get X by itself, we got to play around with this equation a little bit. And this is where it starts to get a little bit confusing. So if we want X to be by itself and its division on this side, what can we do to bring it to the other side? Cross multiplication. So we're going to bring up that X to that side there, and it will be X times, remember brackets beside each other are multiplication, X times equals 7.2. Bracket beside a bracket meaning multiplication again. We've brought up this X since it's division on that side. To bring it to the other, we have to make it multiplication. But now we're probably sitting here going, well, that doesn't really help because then we're going to have 0.6249x when we multiply that. So how could I get the X to stay by itself and move over that 0.6249? Yep. Divide the other side. So since it's multiplication on this side, to bring it to the other side, we have to divide both sides by 0.6249. So that will look like this. X is equal to 7.2 divided by 0.6249. And if we just did that on our calculator, sorry, Haley, I know you're trying to read my scribbles there. I can see it on your face. Like, oh, goodness. You get lazy with this stylus pen for 1 second and it just goes way downhill. So do we have an answer for that yet? Sorry? 11.5. And then what's our measure? Centimeter. Okay. So we've figured out when we have the angle and one of the other sides, how we can solve both the opposite side and how we can solve getting the adjacent side.